Hello everyone, let us see next example of complex number chapter. Prove that nth root of a plus ib plus nth root of a minus ib. This is one complex number. Yeah, nth root means raised to 1 by n, and this is complex conjugate of this number. We have to show that addition of these two number has n real values, means n roots are there, and hence find those of this number. Means once we find out the roots of this complex number, then just put the value of n is equal to 3 here, and a value is equal to 1 and b value is equal to root 3 in the answer. We get this answer for this sub question. Okay, let us start with the we have to put if you want to find out the n real values, means n roots, we want to convert this a plus ib into polar form, where r is under root of this a square plus b square and theta is tan inverse this y upon x, that is b upon a, and therefore a plus ib in polar form becomes r into cos theta plus I sin theta. Now raised to take 1 by n on the both side. First we have to calculate this, then similarly we can write this number also. Therefore a plus ib raised to 1 by n becomes r raised to 1 by n cos theta plus I sin theta raised to 1 by n. Put r raised to as it is because it is a constant. Now here we want n root. To find n roots, we have to use De Moivre's theorem. Therefore add 2k pi to this angle and then take n inside to the angle. We get r is to 1 by n into cos of 2k pi plus theta by n plus I sin 2k pi plus theta by n. Call that equation number 1, where k total number of roots are n. Therefore k value start from 0, 1, 2, 3 up to one number less than the number of roots, that is n minus 1. Now similarly this this we can write it as just replacing positive sign by negative sign. Therefore similarly it means ib raised to 1 by n becomes r raised to 1 upon n into cos of 2k pi plus theta by n minus I sin 2k pi plus theta by n. Now add these two, call this equation number 2. We want addition of these two, therefore add this equation number 1 and equation number 2. We get this addition of two numbers is equal to, if you observe these two RHS side, this is this plus, these two terms are same, one is plus other is minus, that's why this gets cancelled and this gets 2 times the r raised to n 1 by n into cos of 2k pi plus theta upon n. K again same 0 to 1 n minus 1. Now if you observe this answer, on RHS side only real number is there, no complex number. Complex number, if I is there we call it as complex number. On RHS side there is no I value, that's why this is total a real number, that's why we have this n real values. By go on putting values k, we get n real roots of this addition of two complex numbers. First part we have proved. Now for second part, which are obviously n reals because no complex number is there, sign term gets cancelled, that's why I term gets cancelled here. Now put n is equal to 3 in about answer. A is equal to 1, b is equal to root 3 and r is equal to under root of a square plus b square, that is 1 plus root 3 square is 3. Answer is 2. Theta is tan inverse b upon a, that is tan inverse root 3 upon 1, that is pi by 3. Therefore put this value here, we get this, and cube root of 1 plus root 3i plus cube root of 1 minus root 3i is equal to 2 as it is. R is 2 raised to n value is 3, 1 by 3 into cos of 2k pi plus theta upon 3. K values again put n is equal to 3 here, we get 0, 1 up to 3 minus 1, that is 2. Okay, therefore adding this 1 to base same, that's why 1 plus 1 by 3 is 4 by 3. Cos of 2k pi plus theta value is pi by 3 upon 3. Separate out these numbers, we get 2 raised to 4 by 3 into cos of 2k pi by 3 plus pi by 3 into 3, 9. Total k value is 0, 1, 2. You can keep this answer as it is, or just put the values of k is 0, 1, 2, where you get the 3 real roots of this addition of complex numbers. Okay. here we have already putting the values here 0 1 2, we get these three real roots. Let us see next example. Solve z raised to 3 by 3 z raised to 3 z cube is equal to z plus 1 cube. So to solve this equation, that means we have to find out z value or roots of this equation, and hence show that z is equal to minus half plus I upon 2 cot theta by 2. We have to show that z value is this, where theta is 2 and pi by 3. Okay, let us start with the equation. Z cube is equal to z plus 1 raised to 3. Now take this z plus 1 to this LHS side, we get z cube upon z plus 1 cube is equal to here 1. Now combine this indice, we get z upon z plus 1 cube is equal to 1. Now to cancel out this 3, take cube root on both sides, we get z upon z plus 1 is equal to 1 raised to 1 by 3, which is the cube root of unity. And once we get this root raised to 1 by 3, we can apply De Moivre's theorem. Instead of 1, write it as cos 0 plus I sin 0 raised to 1 by 3. Add 2k pi to the angle, we get cos of 2k pi plus I sin 2k pi raised to 1 by 3. Now take 1 by 3 inside to the angle, we get cos of 2k pi by 3 plus I sin 2k pi by 3. And let, as per the notation given in the example, 2k pi instead of n, here we have k, that doesn't matter. Let theta is equal to 2k pi by 3, we get this for our convenience only, cos of theta plus I sin theta. Now one more, we have to do such process, that is n for numerator, d for denominator. We can do this process n upon numerator upon denominator minus numerator on the both side. What we get, this numerator divided by denominator minus this numerator on the both side. That RHS side denominator is 1, that's why cos theta plus I sin theta divided by denominator is 1 minus numerator is cos theta plus I sin theta. Okay, this we can do, like for example, suppose one by 2 is equal to 3 by 6. Okay, now what we have to do both side, by doing this procedure, the value of the equation or equation should be satisfied on both sides. Okay, the numerator is 1 on the both side, numerator is 1 3 here, divided by denominator minus denominator is 2 minus this 1 here, 6 minus 3. Answer should be same or satisfy both sides. 1 upon 1 is equal to 3 upon 3, which is the same on the both side. That's why we can do this process on the both side like this. Now next step will be the z gets cancelled in the denominator 1, that's why LHS becomes 1. This we do it for calculating z on the both side. Okay, by doing this process we get on LHS side z, on RHS side we get cos theta plus I sin theta divided by 1. Remove this bracket, we get minus cos theta minus I sin theta. Okay, now we have to use some trigonometry here. We have this formula 1 minus cos 2 theta is 2 sin square theta. Therefore 1 minus cos theta here becomes single angle, that is 2 sin square theta by 2 here. And sin 2 theta, we know 2 sin theta cos theta, therefore sin theta becomes 2 sin theta by 2 cos theta by 2, making the half angle on the both side. We get this term. Numerator is same, denominator we have this addition of formulas. Now from the denominator, take 2 sin theta by 2 common. In the bracket we have sin theta by 2 minus I cos theta by 2. Now take this bracket to the numerator. We have the reverse of this bracket, means just replace positive sign here. Okay, therefore it becomes cos of theta plus I sin theta into sin theta by 2 plus I cos theta by 2 divided by this 2 sin theta by 2 as it is. Now multiply this both bracket, we get cos theta into sin theta by 2 minus sin theta into cos theta by 2 it becomes my I into I square is minus 1, that's why it becomes minus. Now cos theta into I cos theta by 2 plus I into sin theta by 2. These are two formulas. Therefore we are using here, these are the two formulas, sin A minus B sin A cos B minus cos A sin B. Therefore it becomes sin A cos B minus cos A sin B sin A theta by 2 minus this theta. First angle is sin A, that's why it becomes theta by 2A and theta as B. And plus here I gets common, sin cos becomes this. Cos A cos B plus sin A sin B is cos A minus B. Okay, therefore it becomes cos of theta minus theta by 2 for this two addition, and I is a common term, divided by 2 sin theta by 2 as it is. Okay, let us solve this. Now sin of theta by 2 minus theta becomes common, take bracket common to this bracket, half minus 1 is minus half, plus I cos theta minus theta by 2 is, take theta again common, 1 minus half is half. Again we know sin of minus theta is minus sin theta, therefore it becomes minus sin theta by 2 plus I cos theta by 2 upon 2 sin theta by 2. This denominator is same. Now separate divide, we get minus this half as it is, LHS side is z, plus I cos upon sin is cot theta by 2. Okay, therefore we have these two as it is. We have this answer, z is equal to minus half plus I by 2 cot theta by 2, where theta is, we already assume as 2k pi by 3, means 2n pi by 3, same. K is also integer, n is also integer. Therefore where theta is 2k pi by 3 or 2n pi by 3 as shown in the example. Let us start the next example. Show that root of this is the same example like earlier one. X plus 1 raised to 6 plus x minus 1 raised to 6 is equal to 0. The roots are, we have to find out and show that it is minus I cot 2k plus 1 upon 12 pi, where k is 0, 1, 2, 3, 4, 5. 6 roots are there total. Let us start with the given equation, x plus 1 raised to 6 plus x minus 1 raised to 6 is equal to 0. Take divide by this factor, we get x plus 1 raised to 6 upon x minus 1 raised to 6 plus this here 1 is equal to RHS side is 0. Now take 1 on that side, we get minus 1, and take 6th root on both sides, we get x plus 1 upon x minus 1 as minus 1 raised to 1 by 6. Now we have to solve this LHS side, RHS side. Instead of minus 1, this is 6th root, that's why we have to use here root 3. We get cos minus 1, instead of minus 1 we have to write cos pi plus I sin pi, because we know sin pi is 0, cos pi is minus 1 raised to 1 by 6. Now add 2k pi to the angle as usual, we get to cos of 2k pi plus I sin same angle raised to 1 by 6. Now take pi common and take 1 by 6 inside by using De Moivre's theorem. We get cos of 2k plus 1 upon 6 pi plus I sin same angle, where k start from total 6 roots are there, therefore k should be total number 6, that's why one number less than 6, that is 5. 0, 1, 2, 3 up 4 up to 5. Now we have to prove on our LHS side we have to find root, that means x. Now one more, instead of make this angle as theta, 2k plus 1 upon 6 pi as theta, for convenience we get x minus plus 1 upon x minus 1 is equal to cos theta plus I sin theta. Now in earlier question we used trigonometry, now in this question we have to use for simplicity exponential. We know this is a formula, e raised to I theta is cos theta plus I sin theta, therefore this is equal to e raised to I theta. Now one more procedure or one more we are going to use here, numerator plus denominator upon numerator minus denominator on the both side. Okay, we get this numerator, this is denominator. numerator plus denominator divided by numerator minus denominator. On RHS side also denominator is 1, numerator plus denominator divided by numerator minus denominator. This also gets the logic. If suppose 1 by 2 is equal to 3 by 6, okay, numerator plus denominator means 1 plus 2 upon 1 minus 2 is equal to 3 plus 6 upon 3 minus 6. Let us see whether it is satisfied or not. 1 plus 2 is 3 upon minus 1 is equal to 9 upon this minus 3. Answer is minus 3 is equal to minus 3. Okay, this is the procedure we can do on both sides. Now this is, let us solve. X plus x becomes 2x, 1 gets cancelled, and here x gets cancelled. 1 minus of minus 1 plus 2, 1 plus 1 is 2. Now on RHS side, multiply numerator denominator by this factor. This is one adjustment, e raised to minus I theta by 2, and divide also e raised to minus I theta by 2. Now on LHS side, 2 gets cancelled, x, it becomes x, and on RHS side, e raised to multiply this number by to this bracket, we get e raised to I theta minus I theta by 2. Base is same, that's why index gets add, plus this 1 into this is e raised to minus I theta by 2, divided by e raised to same thing, plus just replace plus by minus here. Okay, now again take theta, I theta common, we get 1 minus half is half, e raised to I theta by 2 plus e raised to minus I theta by 2, divided by e raised to I theta by 2 minus e raised to minus I theta by 2. Now we know one formula, sin theta is e raised to theta minus e raised to minus theta upon 2i, and cos theta is e raised to I theta plus e raised to minus I theta divided by 2. By using this formula, we want here plus is sign there, that's why we have to adjust 2 here, divided by 2, and here we have to adjust 2i, therefore divided a numerator and denominator by 2, and here we want 1 I extra, that's why here in the denominator multiply and divide by I. Okay, these are the two adjustments. Now it becomes sine, it becomes cos, angle is coefficient of I, that is coefficient of I here is theta by 2, divided by here I is as it is, and here is this is the sine, angle is theta by 2. Okay, now if I comes in the denominator, we have to make it in the numerator. For that, multiply and divide numerator and denominator by I. We get, this is cos upon sine becomes cot theta by 2, multiply and divide by I, we get I here, and here I square becomes minus 1, and this I as it is, and cot theta by 2, which is equal to minus I cot theta is 2k plus 1 by 12 pi. 2k, our theta is 2k plus 1 pi by 6, therefore it becomes, again by 2 is there, that's why it becomes cos cot of 2k plus 1 by 1 pi upon 6 into this 2, that is 12, where k start from 0, 1, 2 up to 5. Okay, this is one more simplification of the example using exponential. Instead of trigonometry, we can use this exponential in earlier example also, same type. Okay, now let us see next same type of example. Let's show that root of this equation x plus 1 raised to 7 is equal to x minus 1 raised to 7 r plus minus I cot k pi by 7, where k is only 3 terms, 1, 2, 3. Okay, let us start with the equation. X plus 1 raised to 7 is equal to x minus 1 raised to 7. Take this term on that side, we get this term. Now take index common to numerator and denominator, we get this term. Now take, to cancel this 7, take 1 by 7th root on the both sides, we get x plus 1 upon x minus 1 raised to 1 upon 7. Now again, by using De Moivre's theorem, add 0, cos 0 plus I sin 0 instead of 1, then adding 2k pi and take 1 by 7 inside. By using De Moivre's theorem, we get this k, obviously 7 roots are there, therefore k start from 0, 1, 2 up to 6. Okay, we get this answer, where for simplicity take theta is equal to 2k pi by 7. We get x plus 1 upon x minus 1 is equal to cos theta plus I sin theta, where k is equal to 0, 1, 2, 3, 4, 5 up to 6. Now we have to solve this again as solved earlier. This is the same example like earlier. We get x is equal to minus I cot theta by 2. Don't write in your notebook as solved earlier, just uh, in the earlier example here same. Start with the same example and go on. Just repeat this example. Answer is minus this I cot theta by 2. Okay, therefore answer for this is x is equal to minus art I cot theta by 2. Again theta is replaced by 2k pi by 7 here. Therefore it becomes 2k pi by 7. Again to this 2 and its 2 gets cancelled. Therefore answer is only k pi by 7. And uh, we have this. We have to show this answer as this. Okay. Now let us start by putting k is equal to 0. We get in 1 we get x is equal to here 1. Put k is equal to 0. We get x plus 1 upon x minus 1 is equal to cos 0 plus I sin 0, that is 1. Okay, now if you solve this example equation, we get x plus 1 is equal to 1 into x minus 1. Now x gets cancelled, 1 is equal to minus 1, which is not possible. That's why k is equal to 0 is we are not considering value. That's why in this question k start from 1 to 3 only. Therefore we have now k is equal to 1, 2, 3, 4, 5, 6. 0 is excluded because we get this absurd result, or which is not impossible result from by putting k is equal to 0. Now put k is equal to 1. This equation we get x1 is equal to minus I cot pi by 7. Put k is equal to 2, we get minus I cot 2 pi by 7. Put k is equal to 3, we get minus I cot 3 pi by 7. Total 7 roots are there. Up to third is half part. Now after half part the roots gets repeated. Now put k is equal to 4, we get x4 is equal to minus I cot 4 pi by 7. Now this 4 pi by 7 we can write it as pi minus 3 pi by 7. This angle is one of the above angle 3 pi by 7. Cross multiply we get the same angle 7 pi minus 3 pi, that is 4 pi by 7. Now we know cos of pi minus theta is minus cos theta cot theta, therefore minus minus becomes plus I cot theta, that is I cot 3 pi by 7. Now put k is equal to 5, we had x5 fifth root as minus I cot 5 here, 5 pi by 7. 5 pi by 7 can be written as pi minus 2 pi by 7. Cross multiply you will get the 5 pi by 7. Again 2 pi by 7 is the second angle here. Now we know cot of pi minus theta is minus cos theta, therefore it becomes plus I cot 2 pi by 7. Now last put k is equal to 6, we get x6 as minus I cot 6 pi by 7. Here put k is equal to 6, we get this. Now 6 pi by 7 can be written as pi minus pi by 7. 7 pi minus pi becomes 6 pi by 7. If you cross multiply this we get the same angle. Now again cot of pi minus theta is minus cot theta, it becomes minus minus plus I cot pi by 7. Okay, instead of see total 7 roots are there. Out of that k is equal to 0 is a gives the absurd result. That's why we exclude 0. Now total 6 roots are there. Out of 6 roots we get these 3 roots and these 3 roots. These 3 roots and these 3 roots are same but opposite in sign. Therefore total 3 roots are there only, and one is plus, others are minus. Therefore total roots are plus and minus. I cot k is pi by 7, where k is 1, 2, 3. We get the same result. Okay, this is what we want to prove. In this way 3 roots are same, and the rest of the 3 roots are only opposite sign. Therefore we have only 3 roots plus minus I cot k by 3, where k start from 1, 2 and 3. Okay. Let us see the next example. This is the easy example. This is homework for you. I already solved this example. Find cube root of unity and hence show that they form equilateral triangle in the Aragon diagram. First we have to find the cube root of unity. This example we already solved. The answer for this example is we have to repeat the same example here, same answer, same steps. Answer for this cube root of unity, that means 3 roots of unity, is 1 cos 2 pi by 3 plus I sin 2 pi by 3 and cos 4 pi by 3 plus I sin 4 pi by 3. Okay, and now we have to show these points in Aragon diagram, and we have to show that these 3 points form the equilateral triangle. Equilateral triangle means the triangle whose sides are same in length. Let us start with the this point. This one point is cos 0 plus I sin 0, first root, where r value is 1. There is no number outside this bracket, therefore r is 1. R is 1, here also r is 1, here also r is 1. Only theta values are different. Here theta value is 0, here 2 pi by 3, here 4 pi by 3. That's why in Aragon diagram put x and y axis, and r means 1. Take the circle, draw the circle of certain radius of 1. 1 is the unit. We don't know the unit, that's why we are just by guessing only. Only 4 centimeter or 5 centimeter, take that radius and draw the circle. Okay, now this is the center. Now we have to plot these 3 points. First point, angle is 0, that means this point, A point, is the first uh, uh, root 1. This is the A point with 0 angle and 1 radius. Now second, 2 pi by 3. 2 pi by 3 means 2 into 180 divided by 3. This is the angle. Okay, we can calculate as 2 pi by 3 as 2 into 180 divided by 3. Answer is 120 degree. 120 degree is this angle. Okay, you have to measure properly, and this is the point B, second uh, uh, root in the Aragon diagram. Aragon diagram is just a plotting of point. Now third is point is r is equal to again 1, same radius, and angle is 4 pi by 3. Again 4 pi by 3 is 4 into 180 divided by 3. 240 angle. 240 is this angle. This is the point C. And if you draw these 3 points, you will get this is the equilateral triangle whose lengths are same, sides are same. That's why this cube root of unity, if you plot those points in Aragon diagram, we get equilateral triangle. Therefore triangle ABC is an equilateral triangle. Okay, and this is the 25th question. Now let us move to the circular functions in next lecture.